Alright, so my name's Javier, and I'm going to explain how the input for the button works. So we start off with a while loop that runs between variable I, between 1 and 5. And inside that while loop, we have two possibilities. The button can start off being up and be pushed down, or it can start off being down and be released and going into an up state. If it starts up and you push it down, it'll start counting. However, if it's down and you release it and it goes up, it'll stop counting and it'll tell you how long the button was pushed down for. If the button was pushed down for less than 0.3 seconds, it'll be considered a short push, and it'll input into our input array with 4 slots, the number 1 at whatever index we are. Then it'll increase the index by 1, moving the while loop to the next stage between 1 and 5. If the button was pushed down for more than 0.3 seconds, it's considered a short push, and it'll input a 2 into whatever slot of the array we're in, and it'll also increment the I index by 1. However, if 1.5 seconds pass with no button push, then it'll put in a 0, and it'll also increment the index until we reach 5. Once we reach 5, because there's only 4 slots in the array, the 5th one is once the program reads a 5th button push, it'll reset the loop, allowing you to go again and input another letter.
Hi, my name is Rita, and I'll be explaining how we set up the array so we can get a match and decode the Morse code. So first, we set up the first array that's called Morse letters, and what we did is we pulled up the table of Morse code, and each letter has its own Morse code, and it could have either from 1 to 4 elements, but not all of them are going to have 4 elements. So what we did is we used 3 numbers, 1 for dot, 2 for dash, and 0 for blank. So for example, for A, we put in a dot dash, which is 1, 2, and then 2 blanks, and that's how we put it in the array, and so on for the rest of the letters. Okay, so depending on the length of the button push, we will get either a 1, a 2, or a 0 to match the dot or dash or a blank of each letter. So those pushes will be compared and put into the input array, which is the user array, like the person that's pushing the button. So this input has 4 slots, and it will get filled up with either 1 or 2 or 0s depending on what letter. And then this will get compared to the big Morse letters array. And it'll stop comparing when the Morse letters array is exactly the same as the input array. And once it finds where the match is, then it'll index where the match is, and that'll be a number from 1 to 26. And to convert that to ASCII, we have to add 64. And so then the array will be the letter will be from numbers 65 to 90. For example, 65 is A and 90 is Z.
My name is Josh. This part of the project is the binary comparison for the outputs. Since our project, you can't output just the 8-bit ASCII value to the pins. You have to go individually to decide which bit is going to be turned on, which bit is going to be turned off. So what we did for this, here's a sample line of code for how we did this. Now this is going to be repeated for each of the pins, which is demonstrated by our D8 here, and then the second one here. So how we're going to do this is we're going to compare a 1, which is an on, with the value of the specific light that's going to be turned on. So for example, for this one, we did the letter A, so which is this in ASCII code right here, is at 65. So for the first part, we compared the last bit to a 1. So for example, this one here is compared, it's going to be off for this one. Like if you're comparing these two, it'd be off because it's compared to a 0, so it'd be 0 and a 1, which would be a 0. For the pin to be turned on, it had to be compared to a 1 and a 1. So for example, for the letter A, for the first bit, it's going to be compared 1 to a 1. So for an A, it's going to be, the last pin will be on.
My name is Abubakar, and today I'm going to be showing you the hardware of our projects. Alright, so the project starts from low to high, all the way from 1 to 129. This is the red LED is the 5th slot. After filling the first, second, third slots in the array, the 5th one is the right one. Whether it's with 0s or 1s, it turns on. And the LEDs are all connected to the ground. Okay, now let's look at some examples. Let's say we have A, we should go dot, dash. That should be it, 0, 1, 0, 0, 0, 0, 1. Now let's take another example like E, which should just be a dash. But first we reset. And that should be E. 0, 1, 0, 0, 1, 0, 1. And let's take the last letter of the alphabet, which should be Z. That should be, first we reset them. Z should be dash, dash, dot, dot. And that should be Z, which should be 0, 1, 0, 1, 1, 0, 1, 0, which should be 90. But now, let's take an example where we put something wrong. Let's try, let's say 4 dashes. We should dash, dash, and only the red light pops up because it's an error.